Hi, my name is Chris Snell with Hewlett-Packard Enterprise Storage Division. Today I want to talk about one of the advanced features of the HPE CSI driver for Kubernetes. This is the ability to modify the storage characteristics of persistent volumes that have already been created and are in use by an application. My colleague Michael Matson wrote a blog post back in August of 2020 on developer.hp.com, highlighting the capabilities of the CSI sidecars that have been introduced with the HPE CSI driver. These sidecars within the HPE CSI driver extend the data management capabilities not found within the CSI community and introduce features like volume and snapshot groups, file services, and the volume mutator. The volume mutator CSI sidecar available in the HPE CSI driver allows storage admins to grant access to certain properties that the Kubernetes admin can edit. This allows the admin the ability to configure volumes on demand to meet the needs of the applications even after the volumes have been created. We all know that volume management never stops even after volumes have been provisioned. Many times, applications and workloads change post-deployment with usage, and the application owners and developers need to ensure that the underlying storage can adapt as well. These can include tuning volumes by changing CPG or performance policies or IOPS requirements, changing the provisioning type to enable data reduction features like deduper compression, or syncing data onto volumes prior to moving applications to a new cluster. With that, let me show you how this works. To get started, let's head over to scad.hpedev.io. On the left navigation menu, click on Using, and in the table of contents, you'll find the section on using volume mutations. It is important to read and understand this section as it covers the requirements for the Allow Mutations storage class parameter, as well as some of the limitations. Under each container storage provider, you will see which parameters can be edited for Primera or Nimble storage arrays. For example, some of the parameters you can edit with Primera include the CPG or provisioning type, and with Nimble you can modify various performance parameters, folders, etc. Just be aware that not all parameters are editable. Also note that you won't be able to modify volumes that have snapshots or clones attached to them. So with that, let me show you how to modify a volume. I start with the CSI driver already deployed and configured to talk to my Primera backend. I'm using the latest version of the CSI driver, which as of this video is 1.4. I will start with a standard storage class with all of the necessary parameters to create a thinly provisioned volume on fast class disks using the FCR6 CPG. In order to modify a persistent volume claim or PVC that uses this storage class at a later time, I need to set the Allow Mutations parameter in this storage class, along with the parameters that I want to allow the Kubernetes admin to modify. In my case, I will allow the admin to modify the CPG, snap CPG, and provisioning type. Next, I will create the storage class within the cluster. Now I will request a 200 GB volume with that storage class. With the PVC available, I will attach it to a workload. I'll be using a simple IO ping application for this demo that I will have running in the background to show that all of this is being done on a live workload. I'm going to switch to a split screen here and show the IO ping application running in the right terminal. There won't be anything interesting going on there, but I just want to show that it will be actively running and there won't be any interruptions while I perform all of the changes to the underlying volumes attached to this application. First, I look at my Primera and show you what that volume looks like. As expected, you can see the thin 200 gig volume was created using the CPG FCR6. Now I'll switch back over to Kubernetes and assume the fast class disks are no longer adequate to meet the needs of my application. So I'm going to go ahead and edit the PVC. And under the annotations, add the update to the CPG by defining the csi.hpe.com provisioner and the parameter that I want to edit, which in my case is the CPG. Once you've completed the changes, save the file and exit. Upon exit, you will see the PVC has been edited. The HPE controller driver within the CSI driver will see the modifications and then update the backend volume accordingly. Back in my Primera, I can now see that the volume has been updated. You can see that the snap CPG has been changed immediately. And depending on the size of the volume, it may take some time to tune the volume to the new SSD R6 user CPG. Another important thing to note is that the application never stopped, nor was it interrupted as it kept running throughout this process. The volume modifications are taking place completely transparent to the application. Now I want to mess with the volume some more. I want to enable some data reduction features. Again, I'm going to go in and edit the volume the same way I did before and add another line, changing the provisioning type to reduce, which is specific to Primera. If you are using a Nimble or 3PAR, you would enable compression or dedupe. Again, I will save and exit, and I should see the PVC was edited again. And if I switch back over to the Primera CLI, I will now see that the dedupe and compression features have been enabled on the volume. Again, this was done without interruption to the application. So let's say that you now want to remove a setting that you just modified. You can go back and edit the parameter and set it back to the original setting. So in this case, I want to remove the dedupe and compression, and you can see that the volume was updated accordingly. Finally, I'll show you what it looks like from the SSMC. And because I can't quite figure out what I want to do with this volume quite yet, I am going to change it back to a data reduction volume to see the changes reflected within the SSMC. So I will go ahead and repeat the steps that I've already done. And as you can see, the updates and the conversion to the volume is very quick. This concludes the demo on how to update volumes post-deployment. Again, it is very important to know that volume management never stops, and the ability to dynamically modify your storage to meet your application needs is a critical feature. I am excited to see where these capabilities will be used. For more videos and tutorials on the HPE CSI driver for Kubernetes, go to scad.hpedev.io. If you would like to know more about what HPE Storage is doing with containers, head over to hpe.com/storage/containers. Until next time.